The state is divided into these physiographic regions, which, similar landforms. There's hilly areas, there's flat areas, etc., that kind of thing. And I'm going to get more into this later. But and it also has to do with the glacial history of the area. And vegetation falls out in broad classes generally in these different areas. And so these lighter colors represent prairies and savannas in oak ecosystems primarily. So the areas where oak savannas used to occur, basically. And so the contrast isn't as good on the screen as I hoped it would be, but these areas, you can kind of see. And as you go north, and this is also, I should mention, these areas are dominated by what's called glacial outwash, which is basically when the glaciers released the sediment that they were holding under them. It just sort of washed out into the landscape, and that's what a lot of southern Michigan is. And then as you see, as you go north, it gets greener, and I use green to signify forests, because that seems to make intuitive sense, particularly conifers. So when I'm talking about oak savannas in Michigan, I'm talking about, historically these areas, there's some sort of oak-associated savanna-like ecosystems a little bit further north, but that's the context there. And just to round it out, there are also browns and purples and stuff, and those are just kind of distributed throughout the state. So, big picture context here. Like, when I'm talking about savannas, where does it fit, at least within the state of Michigan? And as you move south into Indiana, Ohio, Illinois, you get more prairie and more savanna, especially moving west. I don't have this level of detail for those states. So, first I'm going to talk about, so keep an eye on here in case you ever get lost. I try to put these down here so you can track what I'm focusing on a particular site, because I do bounce around a bit. So first thing I'm going to talk about, just defining savannas. Where were they found, and what did they look like, what were their characteristics? And then we'll spend a little bit of time talking about how human beings have interacted with savannas over quite a while, since the glaciers receded, basically. And how did they shape us, and how did we shape them? And then within that context, now, so when we talk about restoration, we're talking about things that have only started in the past, decades, basically. So when we're talking about restoration, humans have been managing the landscape in various ways for different purposes since they were humans. But when we're talking about restoration, this intentional, we're trying to create this habitat, manage the specific habitat with these criteria. That's very recent, so that's sort of I'm moving forward in time, I guess. So first of all, what is the savanna? So savanna is another sort of context slide, is an oak ecosystem, the oak savannas that I'm talking about. There's other savannas, like in Africa and whatnot. It's a term that gets thrown around, but when I'm talking about savannas, I'm talking about oak savannas. And so if you think about oak ecosystems, you have prairie on one end with very few trees, and if you look up in the sky, above you, you see mostly sky, right? On the far end, you have a forest, and if you look up in the sky, you see maybe a little bit, but mostly trees, right? And so in the middle is where savannas live. There's the shadier end that people often refer to as woodlands, and this is my sort of classification system, sort of, right? So what one person calls a savanna, another person might not call a savanna, so that's why I'm taking the time to provide the definition. So woodland can sort of grade into forest, and then, of course, when most people think savanna, they think of this sort of grassy area with trees thing. And so this sort of patchy canopy above, lots of herbaceous vegetation, very diverse. Whereas in reality, those aren't discrete things. So that's, if you look at the historical landscape, those patches of forest and woodland and prairie and savanna generally shifted around a little bit. So if you put a pin on the map, so to speak, and then waited about 30 years, it may, at first you may call it a savanna, and maybe it's, in 30 years it's a woodland, and maybe in 50 years it's more open. So it shifted around the landscape, primarily in response to fire, which I'll talk about a lot today because it's really important and really exciting too. So there's we know a lot about the southern Michigan landscape, and actually just the Midwestern landscape from the things that people wrote in the mid and late 1800s, early to late 1800s, as Europeans were sweeping across the continent and settling it, and writing in this Victorian, like, flowery way, which made it sound like a pretty awesome place to convert for our purposes. If you've had a chance to read that, I'm not going to read through that thing, but I like to, you know, picturesque outlines of swells and slopes, you know, it's just like, must have been awesome. So, a few pictures of some spots that we have left so you get an image in your mind. So, I'm talking about the sort of more woodland end of things. This is what we're talking about. The more traditional savanna with the grassy understory. Of course, these are real places that you may be able to visit someday if you're interested. The drier end of savanna, often referred to as a sand savanna or black oak barrens. It's just on sandier soils. But there's unique vegetation associated with these, not just the different oak species. And then we do have a few prairies left, not really in Michigan, this is in Indiana. That's what they look like. They all have billboards in the background. This is right on Highway 41 in Chicagoland, basically. It's going south. We're like, oh my God, there's a prairie there. Somehow it got saved. It's kind of an amazing thing. Okay, so some more language to describe it. So savannas are defined by stand structure, so how the trees are arranged, how dense they are, and that structure is often, again, I'm going to keep on reminding you about fire. Fire is really important. Okay, so there's scattered overstory, primarily oak species, instead of a dense, consistent overstory that you'd expect in a forest. And that results in a variable light environment. So if you're sort of standing on the ground, you can move from one place to another, and there'll be more and less light within a savanna stand, right? And there's enough light that if you look at the ground layer, it's vegetation instead of leaf litter for the most part. And so that's one of the primary sort of differences in between something you call a savanna and something you call a forest. So if you walk in the forest, crunch, 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 right? That leaf litter can tamp down the ability for a lot of species to grow that would be more typical of savannas. So forest species can push up through the leaf litter, savanna species not so much, and they need the light availability too. So there's a diversity of species that there's not like necessarily, this is a healthy debate and probably always will be, savanna species. I might even say it today, prairie species, savanna species. I might say those kinds of things. That's not real necessarily. Because each individual species, which species themselves are sometimes hard to define, but that's a different story. So like, each individual species has a range of requirements, a range of conditions that it can grow under. And in savannas, because the environment is so varied, it accommodates a lot of those species. So since there is a range of light availability, and it's primarily light probably, but there's other factors behind it, is able to accommodate species that on one day you might say that's a forest species, and some other ones you might say, oh, that's a prairie species. Savanna is a place where they can sort of all more likely coexist because there's a lot of sort of heterogeneity is the word that's usually used for that. So.
Graminoids?
Oh, thank you. Yep. Yeah, please do what Ken just did and stop me. Graminoid is a grass or a grass-like species. So things that look like grasses to non-botanists aren't always grasses, so we call them graminoids because we're you know, it's not a grass, it's a sedge and stuff like that, so, but you can call them grasses, that's fine. I'll correct you in the field. And so, these are just 6 species that are associated with savannas. and sometimes with forests and sometimes with prairies, right? But I'm talking about this diversity, and I don't know what you're imagining, so I just thought I'd, give you something concrete to look at. I could have put anything up there. There's lots of different things, but these are some ones I had fairly good pictures of. So. See, there's a sedge. That's a graminoid. It's not a grass. And so I'm going to be using these guys occasionally to represent diversity. Let's see those images again. You messing with the contrast a little bit?
I'm messing with the volume.
Okay. Okay, so I'm going to do a detour, a little bit too much, around the glaciers. So we're going to go all the way back, because everything, what's really important in thinking about the upper Midwest, and particularly Michigan, is just sort of, when you think about what's here and what should be here and whatnot, you have to think about the glaciers, because they were very recently here, more recently than a lot of places, right, on the planet, and shaped the landscape around us. And the way that the glaciers shaped the landscape influenced the way vegetation established and developed. So this is probably Greenland or whatever, but you get the picture. All right, so the last ice sheet that was on Michigan, Wisconsin advance. It advanced on Michigan in these 3 different lobes. So if you've never thought about how glaciers actually work, and I'm not a geologist, I know about glaciers based upon the way that they influence the plant communities that I see now, so it's sort of like backwards. But I have an okay grasp of it, I think. So glaciers sort of move back and forth a lot. It's not like they just came down and then left. So they sort of like scraped and left things here and there. And so what we see around us is a result of that very complex process. But we do know that primarily there was 3 lobes, or more than 3 lobes, but these are the 3 that sort of define what I need to talk about today. And so what they left was the Lake Michigan lobe carved out Lake Michigan and left these ridges here, these moraines, and the Saginaw lobe stopped right here for a little bit and dropped. So we're basically sitting on some of that right now. So the Saginaw lobe went here and then it stopped and left a pile of rocks and dirt. And so in between all these lobes, what we have, where all that glacial outwash is dominant, right? And that's where a lot of savannas are. And they call these interlobate areas between the lobes of the glaciers. And don't worry about the colors specifically, but these are these physiographic regions I showed before, and you can see how, at least that the colors are relatively consistent within these areas. So these are defined by, in large part, the glacial history of the state. And so, for example, this isn't terribly relevant to today, but you can see this blue really well. This is actually old glacial lake plain. So when the lakes were a lot higher, at sort of just after the glacial maximum, the lakes were a lot higher, and there's a lot of flat areas. Some of the areas where savannas were are in these flat areas. So like if you go to Allegan State Game Area, that used to be the bottom of the lake, and that's why it's so flat. But these other areas are more defined by these morainal ridges and outwash. So. And do that one more time. So see how the colors are relatively consistent. It's different colors, but see where we have certain glacial landforms and the ways that the glaciers shape the landscape translates back into, again, this is the pre-settlement vegetation map. So in this area right here, for example, big flat, what's called a T-plane around, if you head towards Charlotte, you end up in that area pretty quick and up towards Lansing. That's an area that was sort of like carved by the moving glaciers. It's flat and it's clay, and it has mostly beech maple forest on it, whereas you get down into here, lots of just varied moraines and glacial outwash, sandier soils, prairies and savannas, and other things. So broad brushes there, but sort of glacial landforms shape the vegetation. That's the one. So you are here. I am too. It's pure Cedar Creek. You see it kind of sits on the edge between those two general regions. And so, coming along Cloverdale Road, I was just noticing today, like pignut hickories and white oaks. And so moving through this oak dominated area, but you get up, you keep going, and there's a beech maple forest, and that's sort of what it continues to be. So we're kind of on the edge between two different areas.
Can you describe what the various colors mean?
I can. So showing up great. So I basically took what is a more specific classification, including oak savanna, prairie, oak hickory forest, etc., and collapsed it in. So the grays are either some sort of savanna, like black oak barrens or white oak savanna, and oak hickory forest, because savanna is sort of, a lot of it was actually forest, but there's a lot of savanna type patches associated with historical oak hickory forest. And then the green is probably mostly beech maple forest in this case. Yeah. And these reds are like swamp forest, I bet. So glaciers, and the glaciers receded, and then plants followed, and animals followed, and people followed too. And the climate changed, it got warmer. And there was this opposite of cool, this hot and dry period, which I think is cool, period sort of somewhere in there. And so this is sort of me pretending to actually graph the mean temperature over time. So it increased to about where it is now, and then there was this peak period where it's hotter and drier. We call the hypsothermal, if you ever want to look it up. And during that time, oak appeared on the landscape. And so this is a pollen record from Wintergreen Lake, is over by Kellogg Biological Station. And so you see this is the sort of peaks of different tree species as recorded in the pollen record in sediments. And so at first we have spruce, fir and pine, which you think of as northern things, right? But they're just following the glaciers up at this point. And then when it got hot and dry, they disappeared and oak appeared on the landscape. Then it kind of settled back down, but oak stayed on the landscape. And why do you think oak stayed on the landscape? Fire. It's either glaciers or fire. That's usually the answers to my questions. So, and here's ragweed, which I think is interesting. I'm assuming that has to do with modern agriculture. So, you can tell a lot from pollen records. I think this is probably, I've never done this, is probably just laborious work to generate these things, but they're cool. So, at the time, at that hot, dry, the hypsothermal, prairie and savanna-like vegetation advanced from the Great Plains, where it was getting established at the time, kind of poked up into, towards the east into what was forest. This thing that we refer to as the Prairie Peninsula. There's an arrow. So, at this time, there's this whole map of, historical prairies and savannas, and they're sort of kind of meshed in together because they are lots of overlap. It's the same landscapes, a lot of the same species. At this point, how do you estimate what's left of something that we didn't have time to document before it disappeared? So far less than 1% of this remains, which I think is a point worth considering, because we rightfully so are concerned about the tropical rainforests and the Amazon, etc. We should be concerned about that. I want to make that 100% clear. There's a lot of that left, and it's going to continue to serve lots of valuable purposes to the future of humanity and the planet. But to put that in context, there's a lot more than 1% of that left. And whereas this vast area right here on this continent used to support these prairies and savannas, there's basically none left. And so that is, when we think about restoration, one of the best arguments for is to save a thing and the organisms that are associated with it. And if something's that rare, and I'll get into this more later, a lot of the species associated with it are rare, and it's a pretty solid argument, I'd say. But it's something that we don't realize. It doesn't have the same, whatever. It's just not advertised as such. And I think it's just gone. And all we have is these cool flowery descriptions from the 1800s, which are nice to read, but it's not nearly as good as the real thing. So savannas, they're a fire-dependent, oak-dominated ecosystem, variable light environments, continuously vegetated ground layer, hyper-diverse, and they're in, like, broadly within these prairie landscapes. And yes, they're all gone. But that's why we do restoration. Okay, so some more about why they're all gone, sort of, but some other stuff too. So I talk about how the fact that there were savannas on the landscape affected the way that we, as Europeans, I'm just going to broad brush that, how Europeans settled this landscape, you know, and how did that shape our culture a little bit, and how did we in turn affect that? But before we get to that, as soon as the glaciers receded, people filled into this landscape. As soon as it was suitable for human habitation, which I guess is a subjective thing, but certainly Native Americans were here right away. So glaciers obliterated all the vegetation, pulled back, and there was, you know, bare soil and whatnot, and vegetation started filling in. As soon as that happened, people were in there doing things with the landscape to feed themselves and to continue their cultures. Okay, so they were hunting, right? They were farming, and they were using a lot of fire. So I told you I was going to say fire a lot. So in large part, the landscape that Europeans encountered wasn't obvious to us at the time, and it's just sort of clicking right now, I think, for a lot of people. The landscape that we think of as the Eden of North America was very aggressively shaped by the previous inhabitants. And of course, there's some more, you know, descriptions from that time period with some pretty insightful stuff, which I think is kind of cool. They knew what was going on. They weren't just sort of like, "Whoa, why are these fires happening?" You know. First of all, they're like, they did it every year to make it tinder. You know, so they're creating forage for animals they hunt. They meaning the Native Americans. And these descriptions they're talking about landscape level fires. So, and this is going to come back when I talk about how we use fire now. Like, we can't use fire in the same way now. The type of fire that shaped the landscape, the impact that it had on the vegetation, we can't do that generally in some public land and whatnot. Because the bigger the fire is, the more impactful it is. It sort of feeds on itself, and you can kill a bigger tree with a bigger fire, maybe, is the rule of thumb. So that's kind of what shaped the distribution of trees and vegetation in much of North America, and probably fire's been used, we've been using fire since we've discovered it as humans and stuff. So that was the landscape. We stepped into a fire-dependent landscape, and here's that vegetation circa 1800 map with some more specifics. Okay, so this is Kalamazoo County, Prairie Ron down here in the south, Grand Prairie, Gull Prairie. I drove through Gull Prairie on the way to get here from Kalamazoo. You can still see the black soil in the spring when, you know, the fields are clear. Yeah, here's the cities. So a lot of cities, and this is not just a Kalamazoo County phenomenon, but wherever there are prairies and adjacent savannas, so these tans are savannas, people tended to settle on the edge of a savanna and a prairie. So that's one thing, right? So the reason these cities are here are, well, the rivers played a part for sure. Don't want to discount that. We need to get around, and rivers were useful for that. But we had the resources we needed on the edges of prairies and savannas. We could go out and farm. The open land didn't have to cut the trees down, but we also had trees to build our houses and heat our homes and whatnot in the savannas. So, and indeed, the first 2 settlers, I believe, in Kalamazoo County in the early 1800s, the Harrises settled on the edge of Genesee Prairie, which is in Oshimo Township. And this guy with the awesome beard settled over here. He's got a cemetery named after him on the corner of 10th and U Avenue, northwest of Schoolcraft there. So these are the first people like, hey, here's this landscape that, where do we put our house? Well, this would be great because we can till this up and farm it, and this would be great because we've got what we need to build homes and other structures and heat our homes. So. Okay, and we can also see the evidence of where people settled. I think this is kind of neat, based upon the earliest cemeteries, and I think it's 1835. They're all about that time period when they were established. So all these cemeteries are just named after the thing that was there when we settled, right? And the thing that is no longer there, right? But it's Genesee Prairie Cemetery, Grand Prairie, Indian Fields, which is where that airport is in Kalamazoo, Gordonette Prairie, this guy right there. So in terms of the way that the historical record or cultural institutions reflect the natural world, this is an interesting one, I think, because it kind of tells a whole story. And there's little bits of things associated with these. So this is a bur oak tree, which is one of the sort of primary savanna species, tend to fringe the edges of prairies. And there it is, sitting on the edge of Gordonette Prairie Cemetery, just sort of like telling just a little piece of the story. There's the cool leaves. Here's the black soil across the street. Genesee Prairie, every once in a while you see one of these species pop up in the middle of it. Here's a smooth blue aster, like a prairie species that's just sort of like still hanging around. And there's some nice bur oak trees on Oakland Drive in Kalamazoo. There's Flowerfield Road near Schoolcraft. Flowerfield. There's Allegan, Prairie Street there. Prairie Edge Church, Prairie View Park. So these are the documents of our history that sometimes these words get thrown around. These ones are accurate, right? So you can name a street Prairie if you want to, but these ones are actually accurate. Okay. All right. So moving on, there's another just great. I just love these quotes, so I just put them up every once in a while. It basically made it easy for us to move around too. So, if you think about trying to, I don't know the last time you tried to pull a carriage through a forest, but I think it was pretty hard. So. But again, that's fire. We did that. And so, if you're a nomadic culture, you can work with fire. If you're a settled culture, fire threatens your livelihood, your well-being. And so that's basically what happened. Europeans started settling, and the fire stopped, and the trees started growing back. So, and oftentimes these fires oak trees they're just pretty awesome things. Fire doesn't kill the tree necessarily. If it's big enough by the time the fire comes through, it just top kills it. it'll start, and you'll see some pictures of what are called oak grubs later, where it just starts sending up shoots from the base. And you go 20 years without fire, those trees are too big. Fire's not going to harm them. So that's basically what happened very rapidly. So the impacts we've had that have led to the decline in savanna, fire suppression is certainly one of them. There are certainly patches of forest on the landscape that historically were savanna, and they've probably been cut over and whatnot, but of course a lot of it was tilled up, a lot of it was grazed. Pretty much every patch of forest in southern Michigan has been grazed, unless the slopes are too steep for animals, for livestock to get on. Those aren't real sheep, cardboard cutouts, by the way. That's at Fort Custer Training Center. They have these sort of mock-up landscapes for soldiers to exist within. It's fascinating place. Signs in Arabic. It's neat. And of course, once you pave it, it's gone. I mean, once you till it, it's kind of gone, but once you pave it, it's gone. And then with urban development comes a lot of invasive species, which if you haven't noticed, that's spotted knapweed. You guys probably all love that plant if you know it. So, I mean, this is sort of like this is habitat destruction sort of 101. This is everything. Specific to savannas, though, I mean, the fire suppression was the first thing that sort of set the ball in motion, and all this stuff followed. And it's sort of like it's an ongoing thing, right? So this is the Chicago region. They have this cool thing called the Oak Ecosystems Project, where they're documenting a lot of historical stuff and getting a lot of people engaged in restoration of oak ecosystems. And so the gray is where oak ecosystems used to exist, and the green here is where they did in 1939 still. And this is based upon interpreting aerial imagery, which it's incredible what you can learn from looking at old pictures. And so in this area, 1938, 1939, the federal government, I don't know which agency, flew over the entire area. Michigan is mostly 1938. The entire state was, taking pictures, so you can, and it's all been, digitized, etc. It's a really cool resource. And so, and now this is 2010. Because it's not, you can't see it real well probably. But the point here being that there was a bit left in 1939. There's way less left now. So it's sort of like this progression or like, attrition really. And so it's just going to continue unless we understand what's happening and broadly value it as a society. And so that's a lofty goal, but it's the one that I'm espousing right now. So. Other reasons to care, as I said earlier, I think I've demonstrated how rare this habitat is. I should probably got that point already. And there's a lot of rare species that I think people can connect with. Like, oh, okay, I want to keep that thing around. It's intrinsically valuable, or it might actually, benefit me directly. Things like red-headed woodpeckers are very specific to savannas. They're still around, but they like the big dead oaks, basically. And you have to have a fairly big patch to support them. Gorgeous bird, though. It's really, if you've ever seen a pileated woodpecker, which is a big and kind of exciting bird to see, I like them better for some reason. They're just, the brightness, just big red head, it's pretty intense to see. Birds, butterflies, I'm going to go on with this. This is a Karner blue butterfly, a savanna-dependent species. It needs the structure. It needs to fly out in the sun and then fly back in the shade. And it won't fly through like 200 meters of forest is all, like it won't go any further. So it really needs that patchy landscape. And it's a federally listed species. A lot of work goes, a lot of savanna restoration work is funded by the attempt to keep this guy around, which is kind of cool. But sort of animals, and I think about plants most of the time, and that's most of the pictures I have are of plants. So this is where these things are hanging on. So this is soybeans. That's a road. And this gets mowed. And there's a couple. You can start to maybe see them, but there's this hairy wild petunia, which is in Michigan is only found presently only a few sites in southern St. Joseph County. But this guy's hanging on because it's short, and the timing of the mowing doesn't wipe it out. So a lot of these things are just hanging on. So what we have is big fields that are grazed and dominated by exotic vegetation, and we have forests. And we don't have this savanna unless we manage it, the patchy sort of light spots, shaded spots, etc. And so savanna species kind of hang on the edges, sometimes inside a fence, poking out from the edge of a shady area. The area they don't mow, I know you can't see it, but trust me, it's there. There's a lead plant right in there, underneath that tree. Between a farm field and a road, poking out of the edge of the woods. So that's where these things are, some of these species that are particularly dependent upon this habitat, this is where they're found. In railroads, so this is overexposed, but there's one right there. They're just kind of like poking out everywhere. Just like, it's not quite right for them ever, but plants are pretty tough usually, and they can kind of lean towards what they need. Western silky aster there. Railroad corridors are one of our, last best hopes for savanna prairie conservation, because most of them were never tilled, and so the microorganisms in the soil are probably still there. The root systems weren't ever disturbed. They burned a lot, even after, just because sparks from the trains, they burned a lot. We sort of accidentally conserved a lot of prairie until some folks caught up to it and be like, hey, that's something worth saving, and it's still there. Not every rail. I'm just going to say Amtrak is not really easy to work with. Other ones are easier to work with in terms of managing the prairies along the corridors. Sometimes you find sketchy botanists walking along the railroads. They're generally harmless. They really are. This one you should keep an eye out for, because he's going to be here a lot this summer, I guess. So keep an eye out for him. He's older and much more like, docile these days. But yeah, here's Brad Slaughter, a good friend of mine. We did here he is photographing these little this is prairie coreopsis. This is a rail line near Niles that got turned into a bike trail, which is cool, but they also incidentally wiped out some things, and we found a few sprigs of that. So we did a project looking for these 5 prairie species because they're dependent upon these habitats. And if you look into, so the state, MNFI manages the database of rare species, and it's only as good as the data that's in there. And a lot of records for a lot of these species are from the 1980s, when some of the original surveys happened. And if you look through there, you're like, oh, that's not there anymore. You can sort of see it. And so we thought we'd do an update just to see what the state was of some of these species, and these are like the canaries in the coal mine. Yeah.
Are you doing anything with these right-of-ways? Because I know I have a friend who's a master gardener, and she's basically saving the wildflowers in a section of the Calhaven Trail. Sue Hodat. Yeah. But here, and this is the problem she had, everything was being mowed. They come in to maintain the trail, and they wipe out all these species. And she's, through getting rid of the garlic mustard and also the other invasive vegetation, and getting to the stop mowing, the stuff is coming back. Like, that's a big problem right there, because prime habitat is being chopped down.
Yeah, I mean, those kind of efforts, these rights of way, cemeteries, the institutional memory is often, like you have somebody who has authority, who can tell, here's how we manage this.
I think it's mostly ignorance.
Right, exactly.
They're into maintaining the trail, they don't like vegetation enclosed, but unfortunately, the place where it's been able to survive, they're going in and mowing it out within a couple of years and destroying everything.
Yep. Yeah, I think it's a case-by-case basis. You need to work with those individuals.
Definitely take stewardship. If you don't have people that are willing to go in, because vegetation will overgrow the trail, and there's a lot of times Sue spends a lot of her time just keeping the vegetation hand trimmed back.
So they don't have to mow.
So it doesn't fall over the trail. Yeah. It's a big part of what she has to do.
So yeah, I'm just throwing this in here just to make fun of Red, and also to sort of just to paint a picture. Starting to bring in some information for you instead of just describing these things. So this number on the bottom is the number of records that were in the database for these species, and then we didn't get to them. Actually, there's more records than that. This is the number that we actually got a chance to go visit the sites over a few years, and this is the number that we found extant, still existing, 100%. So let's just say overall roughly half. I mean, the prairie violet's in obviously in pretty bad shape. There's only one existing population left in the state, and then from that, these are really rough estimates. Number of actual individuals of these species in the state. This is hidden clonal, which means it's hard to sort of sticks up sprigs everywhere from the same rootstock. It's hard to figure out how many individuals there are. So that number is kind of a wild guess. But so yeah, so this is sort of like indicative of the state of prairies and savannas broadly, but a lot of the places where most of the prairie in the state is just tilled. So anything where you find these species is probably a historical savanna. So that's that story. Okay. So the broad brush of this cultural section is, so savannas are both, the presence of savannas are a product of the way humans used to use the land, managing it with fire for, hunting and berry production, warfare, etc. And the current state is, savannas are sort of a victim of the way that land use has changed. So, and that's, Ken, you were asking that question earlier, like how, when we're doing this restoration work, like, can we restore a thing and then let nature take care of it? And that's never been the case. We've always influenced the natural world. There's no reason to stop now. And so when I think about restoration, that's not even an option, right? And especially now when what we're managing is 5 acres. A 5-acre savanna isn't even a savanna, but it's the best we have. Something that used to occur over millions of acres. And now we've got these little chunks here and there that we're doing the best we can. We have to be in there all the time. Like invasive species are the dominant force on the landscape biologically. They're going to keep coming in. Like if we want to save examples of the historical landscape, species that depend on them, etc., we're in there all the time. Just get used to it, I think. So every once in a while you can, there's a lot of hands-on work that's needed the smaller it is. There's areas like, check out Nachusa grasslands in northern Illinois or central Illinois. It's about 4,000 plus acres, which sounds big. It's small for the Nature Conservancy. They like bigger things than that. To me, that sounds big. So that's a big prairie savanna landscape. They can manage it with fire in cooler ways than most of us can. They also have a lot of volunteers, but anyway, starting to digress there, I'll stop. Okay, so you came here to hear about savanna restoration, I think. Who knows? So I've described this sort of process of fire suppression. So this term fire suppressed does get thrown around a lot, and so I kind of wanted to, you know, it tells the story that I've been telling. It's a way to sort of like sum it up. Okay, so that's why, I don't know what this was, I can't remember where this picture's from, but this is what savannas look like now. There might be a little bit of light getting in, but look at that dense understory, and that's what happens in the absence of fire. And so as a result, that heterogeneity, that variability in light environments is gone. There might be a patch here and there, right? And because there's more trees, there's more leaves falling on the forest floor, and because there's less light, there's the savanna species that need the light are not able to compete with the forest species. I told you I'd use those phrases even though they're not real. And so these are the two sort of light availability and leaf litter seem to be the two things that we want to mess with. So when I ask the question, what are we restoring? Obviously it's savanna, but the currency of that, we're aiming for particular species composition and diversity, but these are the things we want to tweak. And so, as I showed in all those pictures of roadsides and whatnot, these things, if they're there, they're still around. Decades of livestock grazing and many sites certainly have wiped out a lot of species. They just, if you don't produce flowers for a couple decades, you're probably, as a plant, you're probably done for. But some are hanging around on the edges. And so the objective is to open it up and change the ground layer from a leaf litter dominated to vegetated. And so these guys can be in there and not on the edges, right? And thrive. And so, okay, so it's fire suppressed. Why don't we just start burning these things? Okay, that might work. It works in some cases. So here's a lead plant. Here's a little close-up so you even have a sense of what I'm talking about. There it is right there. Kind of suppressed by a lot of that leaf litter, right? It's a tough plant, actually. One of the most intense root systems I've ever heard described, although it would take all day probably to dig it up. I wouldn't want to do that. Anyway, so it's kind of hanging out there, suppressed in the shade. You know, fire, I've seen fire work, right? So this is that, you can kind of see some fire scars on this super large tree. Here's a lead plant. Hopefully you can see the difference in color. See how it's kind of yellowish there? It's not really displaying exactly how it is in real life, but it's yellowish there and it's greener and grayer. This is what it looks like when it's healthy, right? So this is a site at Fort Custer Recreation Area where they've just burned a few years, and I've seen the lead plant respond like incredibly.
So that's demonstrating when you've taken an area and you've gone in, you put a burr, and the non-fire resistant trees are dying, right?
Right.
So you're getting the canopy open.
That's right, exactly. So sometimes that works, but oh, sorry, wrong button. So yeah, so maybe one way to restore is just start lighting fires everywhere, prescribed ones, intentional ones. It doesn't always work out that way. I shared that one anecdote. That's one spot where I've seen it work, and I share it as a sort of, it's almost an anomaly. It usually doesn't work that well. I'll show you a picture of what a fire in an oak forest looks like. It's not very dramatic. So a lot of time and money goes into physically removing some of the woody species. So again, the objective is to bring light into the ground layer, right? And to do that, you have to get rid of the shrubs and the trees that are creating the shade. They're also producing leaves again, right? So it's like a double whammy. It's a lot quicker to go in and just cut them out, right? So, but that takes time and money, way more than it would be just to simply burn. So that's one option. We can do it like that. Or we could do both. We could do some cutting and we can do some burning. And that's sort of the people that do this work. Generally, that's what they do. But that's just because it seems to work. You know, it's sort of like the case-by-case experience you have when you do a thing like this seems to work. And based upon the things we're trying to tweak, which is light availability and leaf litter primarily, there's much more to it for sure, but those are the main things. Like it seems like those things respond. So, so here's the fire. You can barely see it. So this is at the McCready Reserve in Jackson County, misused property. This is a oak forest / Savanna burn restoration experiment that I'll tell you about in a sec. But those are the flames right there, and they don't get much higher than that. They're still hot. You still don't want to stand next to them. But it goes, you know, it tends to go really slow, and if you're trying to kill a tree, it's not going to do the trick. So.
And that's happening in early spring, right?
Generally in early spring. That's like the timing of fires can be tailored to different goals, and there's a lot more to be known about that exactly in particular habitats. Should you burn in the summer? Should you burn in the fall even? So McCready Reserve is here in Jackson County, and so this is an experiment that my former boss, big set up with Doug Landis at MSU, along this it's an esker, which is a glacial feature that's kind of cool, this ridge here, had some historical Savannah species on it. So it was like, hey, this is worth restoring. And so they set up all these plots that were only burned, plots that were thinned and burned, as I was describing, and later on they established some control plots that sort of weren't being managed at all. And here they are sort of randomly distributed across this ridge to get at this question, like, what happens? Like, how does the, Savannah restoring respond to these different things? Like, if we just burn, do we get the same result as thinning and burning? Do we get the same level of diversity? Or does it happen more slowly? Do they end up going completely different directions in terms of which species are there? These are the questions that are worth studying. And so, as of when this data was available, first of all, adding the thinning, believe it or not, does increase the light availability. So, hey, that's cool. So burning, you can sort of see like the differences in sort of, if you just burn, you're really just opening up like you're just killing some shrubs and some smaller trees. You're not killing the big trees, but these guys, thinning and burning definitely creates a better light environment, and that's helpful, but that's just one step. What is the result that we get from that? And actually it shows that the combination of thinning and burning does actually increase the diversity via increasing light availability. This is particularly important for native species, where these full bars are native species, and these are exotic species. There's not, exotic pressure isn't really too bad at this site apparently. So, okay, so we studied this. These are experimental plots set up to answer a specific question. Studied this at this single site, and this has been generally found elsewhere. But science, yes?
Any idea where thinning only and not burning?
That's in this one.
Oh, okay.
Yeah, exactly. That's a good question. So yeah, so that's one thing when they set up that experiment, I think they're kind of space limited. They wanted as much replication of the different management units as possible. And so, I wasn't there when they set that up, but. So, when I was doing my postdoc with Lars, the project I was working on, funded through the Great Lakes Restoration Initiative, which if you're paying attention to the news, is always being cut and then restored to funding. It's kind of exciting. this time last year, I was like, do I have a job? So this is a collaboration. These guys at USGS down at Lake Michigan Ecological Research Station, Indiana Dunes, Rolf and Noel brought us in to help out with a part of a project that Oak Savannah restoration project they were working on, and got a lot of help from Ashley, who's the field tech, last summer, and did a lot of great work with us. So we set up to incorporate that additional element, John. So what we did, we know that this importance of thinning and burning has been demonstrated, a handful of places on individual sites. But in order to understand the broader implications of those different management approaches, we set out to explore how those restoration options played out at a much larger scale, and how did they, did you get the same result here as here, basically? Or to the extent that they're different, can we explain why? So sort of like dig in a little bit deeper and understand what's going on. So this is last year's sites. There's 48 sites here. Next week we're getting out and starting in on the second half. So we're gonna have 100 sites by the end of this summer. So yeah, we looked for sites. So this is us talking to land managers and saying, how have you been managing the land? Do you have spots that have only ever been cut? Do you have spots that have only ever been burned? Do you have spots where you've done both? Do you have spots that you think would support Savannah that you have never managed? So it's this sort of approach where you basically look at a lot of maps and point at it and say, yeah, that's a good spot, that's a good spot. So we sort of assembled these sites together based upon conversations with the people that are doing this work on the ground, and put these clusters of sites together. So the combination of these management histories are replicated, at the larger scale. So here's a cluster with all those management histories. There's actually 3 up here in Manistee. So we did, yeah.
Is there a legend for this? I mean, is the orange like state land?
Yeah.
Is that how this works?
Sorry, I changed colors a lot, so I decided to not get too confusing, but I will answer that. Okay. This is just a Google map I made to keep track of things.
Right.
Orange means thin and burn, red means burn, green means unmanaged control, and the brown means just thin. So that's just
a variety of ownership of property. Could be state lands, could be conservancies, could be private owners. Is that how this?
Yep. Yeah, actually, I'm going to show that in just a second. So we collected a lot of data, but we definitely collected data about the plant community that's there, so we could assess diversity and which species were responding to the management. Were they, Savannah species or whatnot? Yeah.
Were all these properties managed as Oak Savannahs by the property owners?
Yeah, that was one of the things that when we approached people, here I'll just put this up.
Got it.
When I approached all these people, I said, are you managing these? Why, are you managing these to be Oak Savannah? Because that's the whole point of assessing the outcome, right? So they had to have Oak Savannah in mind, based upon that broad definition that I showed you way back years ago when I was at the early parts of this presentation. It was like a long time ago. So that I described to them continuously vegetated ground layer, etc. That sort of definition of Savannah. So it includes what people would call oak woodland. Did you have a question?
Yeah. What happens when you unmanage them? Do they grow themselves or what?
Yeah. So those are ones that what that word means there is just that people have not intentionally taken any action. It's not like they were being managed and they stopped. It's like they were never being managed at all. Does that make sense?
So he wants to, and I think he wants to know a little bit what is the outcome on that.
Right.
How do they survive on their own?
Right, yeah, so nature just takes its course. So basically what happens, I'll show a couple pictures. The ones that aren't being managed are are just dense forests, basically, and not savannas.
You could say pristine, right, but it's never had any interaction. That's what you're getting at, right?
I guess so, that's value laden, but yeah.
So it shifts. So it shifts then, like nature takes over, it will shift what grows and how depending on.
And really, so to put from the experimental design standpoint of, you know, because this is a study that's trying to like carve out an answer from all this sort of variation. We're viewing the unmanaged or control sites as this is what it would look like if you didn't. This is what a savanna in this particular landscape would look like if you didn't do one of these things, right? And if you did one of these things, it would be a savanna otherwise, right? So, yeah.
You look at a lot of plots in the Kalamazoo area.
Yep.
You tried working, or why are you working with the Kalamazoo Nature Center?
They don't have any savanna.
Okay.
Yep, they have the Harris Prairie over by Delhaven Trailhead would probably qualify, and that was on the list. But so what I tried to do is, for all these, you know, clusters of sites that had as much of this going on as possible, right? So, and then, so they're comparable, so I'm controlling for as much of the other variation, who knows what, between sites. So I tried to make them as similar as possible, and so that sort of like some other sites that may have worked, no longer worked. For example, Portman Preserve, Wolf Tree are two southwest preserves. I'm using those because they're both on south-facing slopes, and they're both on the moraine. So like these kind of things, I try to like be as consistent within those groups as possible.
And then when you say thin only, does that include pesticides or like herbicide use?
Some of it does, yeah. So there's a lot of, because of the way that these sites were selected, there's a lot of slop in there. But the broad brushes of it, and it's such a large geographic area, as we talked about, I said, okay, that's just the nature of the game. You can, so when I'm talking about thinning, I'm talking about just killing woody species or cutting woody species. So trees, shrubs, everything, and I'm not going to get into it here, but we collected data to sort of put that in a context. So we measured stumps to assess how intense the cutting was. So we have data on the density of trees and also the density of stumps. So we could create a proportional value to say this intensity of thinning had this effect. So we put all this stuff in a statistical model, and it either corrects for that variation or points to what is causing the variation that we see in whatever we're looking at. So I can get into the weeds if you want, but decided that was not thing to do today. So here is just, that's a quadrant frame, plastic frame, just to sort of demonstrate, like we're basically going to these sites and running a line and collecting data in a square meter plot. Yeah.
So what kind of size are these areas? Broad brush, smallest to largest?
The largest are just landscapes. So Elegant State Game Area, I'm going to show you a slide in a sec. That's a landscape where we're just, the management units are huge, are just tens of acres, and it's embedded in a landscape where there's similar vegetation. Whereas some of the smaller ones, you know, basically closer to human habitation, you know, maybe like 10 acres or 5. Yeah, more like 5 actually.
Okay.
Yeah. So there's a lot of that too, and that's something, of course, we can plug that number in and. Yeah.
I wonder what that USGS is.
That's the Indiana Dunes. So yeah, USGS hasn't. That's our collaborators on the project too, and so USGS has an office at Indiana Dunes. Yep.
I see.
Yeah, a science office. So they do a lot of water quality related stuff, but they also do this terrestrial ecology too. Oh, as promised, Allegan. So here's the Allegan County, just to the west of us here. This is the edge of Berry County. So there's these historical patches of what are called oak pine barrens. So it's a little bit different over there. There's a, as you get closer to Lake Michigan, you pick up more northern species because the climate is slightly more moderate because of the lake. And so these here, these tan patches are sort of historical savanna patches. And a lot of that is the Allegan State Game Area. It's sandy, you can't grow anything there, the state owns it, that's the story. But because of that, there's lots of cool remnant habitat. And so these are actual habitat patches that are high quality oak pine barrens from MNFI's database. So these are shapes that were created to signify this is where the good stuff is.
That's the purple patches, right?
Yeah, exactly. Yeah, yes, exactly. They're the smaller purple patches. So here's one of them, the I don't know what you guys think it looks like from Star Wars. This is a cool spot. This is a site that in 1938 you can kind of see how open it is. This is open. Here's some trees right here. So it was a very open savanna then, and probably. I don't know the exact history, and it probably wasn't ever, it's possible it wasn't ever tilled. It's pretty high quality. I'd be surprised if it was ever tilled.
Swan Creek.
Yeah, can you give us
there?
This is just south of the Kalamazoo River, the Ottawa Marsh. Actually, this is sort of in that part of the game area. Yeah. But there's great savanna patches near Swan Creek, actually, closer to the headquarters. So you fast forward to 1998. And you start to see like how much we can actually learn from this aerial imagery. So, like open, far less open. So it's there wasn't a whole lot of management with necessarily biodiversity in mind until about this time actually. So it's a good thing we have a good set of imagery from this time.
So is that road east and west? Is that one on 26th?
Mm-hmm. That's the one. Exactly.
And was this land in state ownership during this period that you're talking about here?
Oh, it's definitely then. I'm not sure when the game area was created. It definitely was by 1998.
But it definitely wasn't a CCC project where they went in and did tree plantings.
Yeah, thankfully they didn't plant any red pines here because that would.
Yeah.
Although a lot of the places where red pines were planted, like we don't know that it was a bad thing because red pines just sort of obliterate what was there to create it into just a. Not a whole lot grows under those stands of red pine. So, good intentions. Jobs. That's good. And then fast forward to recently, it's closing in a lot, but it's still got that patchy look, and so it still is savanna, and it's high quality. So here's kind of what it looks like, and this would have been last year. I think they had burned it in 2016, but it's still, so these grubs this is like a year's worth of oak grub. So you can kind of get a picture of like, those guys were chopped down to the ground by fire, and this is basically a year and a half's worth of growth. So they're like, they're going.
And the fill trees were oaks, right? That's what was naturally filling in that area.
Yep.
Am I getting that right?
Yep. Okay. Mostly white oak, some black oak, and there is a fair amount of jack pine and white pine in this area too. Like a natural component of the system. Okay, so that just sort of gives you an idea of sort of one of the sites, just sort of like that sort of targeting with this in mind. And so that's a thinned and burned site. So that's kind of like what you get with that. Here's so these next 4 spots are all kind of within, a couple square mile area in that same sort of landscape. So this is across the road basically, where they haven't done any thinning and burning. And it's shady, right? You can see a lot of low growth right there. Here's a spot down the road that hasn't been burned, but there was a timber cut. At least one timber cut, and so trees are resprouting from that. It's kind of dense. I couldn't really even get a good perspective picture because it's so kind of like.
And what was being taken out of there? The jack pine and the pine, basically?
I think oak is the primary target.
Just
in that area.
thinning it out.
Yeah, and this was a commercial timber cut in this case. So there's a lot of that going on. And this is a case where, you know, it's not necessarily a bad thing. I mean, it's never really a bad thing. This is a spot where it's very beneficial for this habitat. You know,
Well, is the way that people go into harvest timber the way that a Savannah manager would go in?
Not necessarily. Yeah, there's a lot of fine lines one needs to walk. But
That's what I was going to ask. I mean, a forestry operation isn't going to treat stumps.
right,
It's
exactly.
a critical part to achieving what we're trying to do.
Right, and so you can do a timber cut and follow it up with a fire, right, if the timing is right. So, and this is one where it didn't happen that way, right? Because there's, you know, a crew, and state land, the way they do fire is there's certain restrictions. There's a limited crew. Not just any state employee can participate in the fire crew. So there's a crew that cruises around different parts of the state and does all the burning. So anyway, and here's a site that, you know, that would have looked like this, right, except for it was burned. And it's a little bit more open. You can see a lot more vegetation on the ground. So it kind of paints that picture. And then again, here's that, back to that same spot that I showed you before. This is looking the opposite direction, but, you know, thinned and burned. This is all Pennsylvania sedge, if you care to know, which is one of the dominant graminoid species that cover the floor of a savanna often. So, any, you know, widely spaced oaks. This is a site that's managed for Karner blue butterflies specifically, so there's money that goes into it. It's also managed with National Wild Turkey Federation, I think it is, money, because, and I'll come back to this, I think, the way you manage a savanna can help game species too. So if you're managing for Karner blue butterfly, you may also be managing for wild turkeys, which broadens your audience drastically. So
When you do this, do the surviving trees grow differently? The hardy ones who can survive burn? Or is it mainly the understory, the foreground that actually does better differently?
yeah,
Do the surviving trees act any differently, grow any differently, or not really?
I'm sure a little bit. I mean, they've got more room to stretch out, maybe.
So that's not the real target.
That's not the target, no. No, the target is definitely getting more, you know, the two things about light availability and reducing the litter. Some species that are particular to these habitats respond directly to the fire, particularly legumes, species in the pea family like lupin, which is blooming right now, go see some. They respond. So fire does a lot of things, and we could talk about it all day. One of the things it does is it volatilizes a lot of nutrients, and so it sterilizes, not completely, but it reduces fertility. And so, legumes are able to fix their own nitrogen. Well, they associate with microbes that fix the nitrogen. And so when nitrogen is scarce in an environment, legumes do well because they can get the nitrogen by associating with rhizobia bacteria, right? So there's those kinds of things going on too, in how different species respond, and there's probably a lot more to know, and it probably has to do with microbes in one way or another. It seems to be, every cool answer is always like, oh, it was the microbes. So glaciers, it was the fires, and the microbes. So back to this bigger picture. Now I'm just going to show a couple graphs of what we found from the first year of looking at this data. Like I said, we're going to expand up this way. By we, I don't really mean we so much because I do have a new job, so I'm mostly doing that one. So we're going to expand up to here and fill in some of these blanks and have like about 100 sites by the end of the summer. And hopefully answer some of these questions on a fine scale. So these are the different management. So the most extreme, thin and burn, maybe on one side, and then compare compared to unmanaged. So this is sort of across the board how sites responded to management. And as you can see, when you don't do anything, there's a lot of litter cover as you expect in a forest. And the combination of thinning and burning actually has a pretty measurable effect compared to that. So it sort of steps down. I found it interesting that it shook out this way, where burning does burn up the leaf litter, but we're not always in these sites right after a burn happened, right? So we're in these sites, maybe 2, 3, 5, 10 years after a burn happened. It just has that sort of history associated with it. So really, you reduce the number of trees directly, they drop less leaves, I guess, is the story there. So again, the combination of thinning and burning achieved the goal that we were after, right? That managers are after, I should say. And also, with respect to light availability, the other sort of target that we're looking at in terms of the structure of these sites. So, compared to unmanaged controls, which are very shady, so maybe 15% light availability on average, thinning and burning increased light availability drastically. So, and that's, as far as what we know about how these systems work, as I've described it to you, that's what the species that we're trying to manage for, that's what they were going to respond to, right? It's the thought process.
How did you measure percent light availability?
Good question. It's not literally that. So that's not really, it's really just canopy openness is what we measured. So a percent using what's called a spherical densiometer,
Okay.
which sounds fancier than it is. It's a convex mirror that you hold in your hand like this, and it's got little hatch marks on it. And you literally just count the number of quarter squares that are filled or not filled, however you want to do it. So there is a tool that you can actually literally measure. It's PAR, photosynthetically active radiation, which is more relevant to how plants grow. So maybe we should do that too, because the plant is responding to how much canopy openness there is, but what it's really responding to is how many photons are getting down to the ground, right? So.
Well, you don't want to change that now.
Yeah, exactly.
Then you have another variable.
Exactly. Yeah, I mean, we could go around to all the sites and measure that once, I think, and that would, yeah. We want more variables, We can always choose not to use them. And so we're looking at, litter cover and light availability, and just one way to assess how good is the plant community doing is just to look at diversity, species richness. And so that's what I'm going to show you here. There's some other, the other answers are far more complicated, right? So we reduced the amount of litter cover, right, with thinning and burning, and this shows that indeed, as the percent cover of litter increases in these sites, diversity decreases. So, and as light availability increases, diversity increases. Okay, so just to put it back into context, this is about where the thin and burn plots were on average, and this is where the unmanaged plots were. So, higher diversity in the thin and burn plots, lower diversity in the unmanaged controls. So, the factors here's the same for light availability. So the take home of these two slides, all these dots and stats and whatnot, is that when you compare thinned and burned sites or plots to unmanaged plots, you get basically the three things that we want to maximize, right? Is low litter, high light, and high diversity. So this is sort of beginning the argument for, yes, doing the combination of thinning and burning across this large area, all this, soils are different, etc. Everything's different about these sites. But even with all that taken into consideration, the approach that we think is the best, but also the most expensive and time-consuming, is the one that gets us the result that we want. Yeah.
Just curious, when you say native species, is that both plant and animal?
No, this is just plants.
Just plant.
This is just plants. Yep. Exactly. So that's what I just said. This is like a simpler way of saying it, probably. Less littering, more light equals higher diversity, right? And we got that. We maximized that equation by thinning the bird, right? And so we were able to get all these guys inside the picture, not on the edge of it, which is what we were trying to do, and metaphorically, I guess. Okay, so any questions as I transition towards the end here? Yeah.
Is it known whether or not oaks in oak savanna are going to have less problems than oak forest with regard to oak wilt?
That's complicated. Yeah, I don't know. I don't know the answer to that.
Because there's root transmission.
Right, because they're less dense.
Yeah.
They could.
It hasn't really been looked at.
Yeah, because oak wilt is transferred. So under the ground, the oak roots are all, in contact with each other, and oak wilt spreads. And oak wilt is just kills them. Right? There's kind of nothing you can do. So when oak wilt shows up in a stand, dig a big ditch and sever those connections and quarantine it. And so Kenneth suggested maybe, since the density of oaks is less in oak savannas, maybe there wouldn't be as big of a problem. Who knows? Maybe the roots are still connected and it doesn't matter. They're also if they're being managed with cutting and fire, they're more stressed. And oak wilt's a fungus, so they might be more susceptible to the fungus. Who knows? Somebody should look into that. Yeah.
Before you move on, how do you control for, I thought just left.
You want to look at a picture?
How do you control for managers that actively planted seeds
good question.
or forbs or things like that? Because you're finding which is the best
we try to
diversity.
Right, because that's an absolutely spot on question. We try to avoid it as much as possible. And so there was a couple sites where there was some, and we try to avoid those. We asked them, where did you do that? We try to avoid those areas. And then to the extent that we couldn't do that, we sort of compared the results with and without those species. So if that species that's contributing to that diversity was actually sown, just sort of take it out and see if the answer is different. So, yeah.
One more.
Yeah.
What animals were native to the oak savannas?
Oh, man, great question. Lots and lots of them. So certainly turkeys, wild turkeys. And I showed that the red-headed woodpecker. There's a whole bunch of birds. I'm not up on birds. Maybe somebody else can answer that question. There's a whole lot of butterflies and moths that are specifically dependent upon that habitat. There's a lot of littler insects too. I know there's something called a Kansas leafhopper, for example. That's just one that pops into my head. It's like one of these little things that really likes those grasses. That's what it feeds on. So there's all kinds of things. But lots of the things that are still around, I'm sure there was possum and raccoon and the kind of things that the bigger mammals that we see. But maybe somebody else can answer that better. Yeah.
Well, I did some research about 20 years ago, and I wish I could remember one of the natural history magazines did a really great article about blue jays and the effect that they have.
There you go.
Because they harvest, believe it or not, acorns, and they'll stuff a whole bunch of them into their craw or whatever you want to say, and then they fly away with it to stash somewhere. Well, inevitably they lose some along the way, and that's one of the ways that the oak savannas would be propagated and expanded. It was a fascinating article. I wish I could dig it up.
I think blue jays, more than any other bird, seem to be important for oak dispersal. Yeah.
I'm going to play off of his question a little bit, Tyler. I know you're a botanist.
Yep. It's right there in the business card, actually.
Yeah. But, we do these restorations, and we bring back all these plants. How do we get the fauna, the leafhoppers and the grasshoppers and all the things that actually do a lot of that management stuff for us?
Right.
Back into these things, whether it's savanna or prairie. I'll say that because I'm the researcher studying prairie restorations, how do we get these prairies to go back to the fauna part of things? I mean, we get the great plants, but how do we bring in that other piece that doesn't just appear by seeding or?
I mean, I don't know. I mean, that's a good question to ask, because it's not part of the thought process usually. Restoration. If you're managing for Karner blue butterflies or whatever, then you're focused on it. If you're just doing general restoration for prairies or whatever, the way that the field developed was, you know, like the Field of Dreams kind of scenario, where you put plants in there and everything will come together. But I think aside from actually physically moving things in, you know, assisted dispersal or whatever, a more nuanced understanding of how the system functions is important. And so it's not just because you like out here, just because you plant prairie plants, you don't necessarily have a prairie. For example, there's no bison. Like, without bison, is it still a prairie? You know, the way that maybe some of those smaller organisms depended upon the way that bison, you know, their patterns of grazing and following and whatnot. Those kinds of things. So, and the microbes may have, that aren't there in the soil, etc. Like, I think that we have a, you know, that's a great open-ended question that you can throw a lot of specific questions at.
Gives me a research program.
Absolutely, endlessly, yeah.
And you mentioned earlier that we're at 1% left of Oak Savannah.
It's actually like 0.0001 probably.
So once you get to that level, have you gone past the point of no return with species, it would seem like?
A lot of them, yeah. Like I showed you those 5 species that Brad and I looked at in Michigan. That's just Michigan. Those species are all secure, is the term used globally, right? So step over in Indiana, Illinois, in Wisconsin, there's enough of those guys around. But other species, that's not necessarily the case. And, right, so just because there's this idea called an extinction debt, so they might still be around. You can still go out and see the thing, but if you were to actually study the population growth or whatever, and get a good estimate, you'd see it's going down and down and down and down. It's on its way to, you know, that's why I think I used the word attrition at some point, because that's like a, you know, that's the term that comes to mind. Things are just sort of like slowly disappearing, but they're still around, and we can definitely, like plants, we can grow plants. Usually, some of them are harder than others, but we can produce seed, and we can grow plants from seed. You know, animals are harder to rear usually, but you know, Cedar butterflies and Karner blue butterflies are, you know, zoos are rearing them and trying to reintroduce them into places. So, and I think that's why a lot of people focus on species, and I always try to focus on like the ecosystem or the habitat or the community, because if we don't have a place for these things to thrive, and I think that's kind of what you're getting at there, then all we have is sort of like a museum or a zoo of like, here's all these species that used to be all over the place, and now they're all on life support, and we can still look at them. Isn't that cool? But no, it's not. So, yeah.
I think if you want a good example of that, you look at the Karner blue butterfly, right, where they did find an existing population in Allegan. So then, and it was almost gone.
Right, it's doing.
The butterfly was almost gone.
Phenomenal.
So then they started managing, and so if you want to watch an example of where that can come back, I think that's a good one over in Allegan.
But then you can look at the Cedar. So these are 2 federally endangered butterflies, like not just rare in Michigan, but rare on the planet, global. And so yeah, Karner blue, there was a landscape that could be managed, and there was the will and the knowledge to manage it, and it's doing pretty good for a rare species. It's not just in Allegan, it's elsewhere.
There are secondary effects. I mean, you have this wedge species that allows you to get into it or manage the habitat.
Yeah, that's true.
And then you get all these other species that
that's a good point. I was going to bring it back to the Cedar, which not the same story. It's like it occurs in fens, and we're sort of like catching up to understanding its natural history. Managing, a lot of money is going into managing fens, which is great because there's a lot of species that are associated with them, and they have water quality. They do a lot for us that we don't pay attention to usually. But that species, I'm pretty sure, is on its way out. Like this, it just within the past 20 years that I've been paying attention, went down from something. I don't know the numbers actually. Maybe somebody in the room does, but half the populations that were around 20 years ago are gone now. Or maybe even a more recent time scale. So that's one that it's, happens that way. But as long as that thing's around, there's going to be a lot of money thrown into fen management. And I think that's great. Because, you manage for a Mitchell Cedar, you're getting a lot else. Okay. I'm going to, this is just sort of like getting back to the big picture. This is a lovely picture I like, but this is a lead plant. This is in Texas Township, if you've ever been down there. This, the site for sale, there's these, it's a special concern species, so it's not like protected legally in the state, but it's pretty rare. The sun's going down, and there's this like lead plant that somebody drove over with like a bulldozer or something. It's sort of like a nice image, I think. All right, so I talked about one more field season for that study, but it's kind of like the conversation we're having right now, like identifying sites that have potential for savanna and harnessing the resources to restore them and conserve them. Restoring sites that, like here, there's the sand savanna, or whatever. I don't know what you guys call it, dry sand prairie, maybe. Like, I use these terms interchangeably, but there's a site that had some potential and some throwing some species and making it more of a prairie or more of a savanna. Identifying sites and out by the Grand Prairie, that's like, Grand Canyon, Little Grand Canyon. That's a site that was, it's been in agriculture. So creating habitats, we can always do that, and then identifying sites that have potential, they're still out there, and so I'm always sort of like, don't drive behind me. I'm always looking, weaving and whatnot. Just stay off the roads. Yeah.
When you showed your graph, you had an R value, your R-squared value for litter they were more correlated with species diversity.
For sure.
And you said you have a lot of plants in agriculture and livestock areas, right?
Yeah, that's the history of most of those sites, yeah.
Could you try working with farmers to maybe use their livestock to selectively graze and keep down on that leaf litter?
Absolutely.
With that, and then maybe work with more farmers, because it's not that they want to destroy everything.
No, they're just being efficient to get what they need.
Well, they're trying to make a living themselves, so could you kind of have like a symbiotic relationship with them and maybe restore more of the areas, especially since they're in southern Michigan, which is a huge agricultural hub because of the soil. Yeah, so to be clear, I was talking about the history of the sites. So all the sites that I collected data in are there's no more livestock on them, I think, for the most part. But I mean, like some of the sites.
But other sites you can definitely use, and that's sort of like, here, so I'll come back to it, sorry. There's the philosophy that you're describing is exactly something that I did want to touch on in terms of there's a lot of land that's being managed for deer and turkey and whatnot. And that's a lot of potential to harness other people's needs. It's like what becomes a problem is when we say we got to do conservation here, we got to do other things here, and if we can incorporate all those things into the same land and get the things we need out of it, like the enjoyment and nourishment and etc. of hunting, and the livelihood of agriculture, if we incorporate all those things, I think there's so much untapped potential there that's a way to expand the impact of everything that everybody's doing. Okay, sorry. Is there anything else you wanted to say about that?
No, just when you said the deer, the sheep graze in the same way that deers do because they have around the same stomach structure. And so when I say livestock, and most people think cow grazing, but I mean like smaller species too that aren't scaring off the deer, but there's like, I have sheep and we have turkeys and fawns and deers all over the place with our sheep.
They're all compatible.
Yeah, we don't
Goats are great. Goats are the best.
Yes.
especially for cleanup, because goats love those things.
And species too.
So, I'm just throwing out ideas. So that's, I mean, we always have to be creative, and I think that's, somebody like you who knows what you're talking about in, both worlds, that's fantastic. Like, we need to get out of our little camps. Like, it's not like the tree huggers versus the farmers anymore. Like, we need to get rid of that. That's, it's a mentality that I think a lot of people like to stay in their camps and feel threatened by what other people are doing. But it's all, we're all in on it together, whether we realize it or not. So, and make some, make some compromises. It's okay, right? You're still, you're getting like a, less than perfect result versus no result at all, I guess is what I'm talking. And the other thing I'm throwing out here, I forgot to mention, it says Mount Hope Cemetery in Middleville. Go check it out. It's a Savannah remnant. And I've shown this picture a lot because it sort of typifies it. Oops, wrong way. Oh yeah, and then the other sort of human element that I wanted just to touch on is like, and one of the things I'm doing today is sort of maybe bringing some people more into the loop on like what is this work, why to do it, etc. And I think the more people that are plugged in, so this is a broad effort in the Chicago area. A lot of citizen scientists, maybe you've heard that term before, a lot of people doing the actual work. And when people are doing the actual work, they become invested in it. They tell their friends and neighbors, they care about it, and so that, it's like more, it's like a neighborhood watch program, but for nature. So, I think that's it. Yep, and those are my kids. Yep.